Our final honoree of the evening is Louis Pouzin. Louis is being recognized for his early contributions to the concept of the datagram and connectionless networks. And early in his career, Pouzin worked on the influential CTSS early time-sharing system at MIT. In 1971, Pouzin was asked to develop a national computer network for France, which led to the development of the Cyclade network. Cyclade was developed around datagrams, packets of data that could be sent across disparate networks, allowing each piece of a message to take a different path and arrive in any order. Pouzin's work on datagrams helped lay the foundation for parts of TCP/IP Internet Protocol. Tonight, we honor Louis Pouzin and present a short film where he shares his contributions to computing.
After graduating from the École Polytechnique, Louis Pouzin became fascinated by a new field, computing. He took a job at Machinesbull, working on mainframes to pursue his interest.
I didn't understand programming yet. So I asked my boss to find me a place and try to get to the States, the United States, for some time for the purpose of learning English and learning programming.
Pouzin contacted Professor Fernando J. Corbato of MIT's groundbreaking Compatible Time-Sharing System, CTSS.
After a few weeks, I got a proposal from Corbato to work at MIT to develop commands for the CTSS. Well, I wrote 1, 2, 3, 4 commands. Maybe I wrote something like 20 or 50. My colleagues were happy because they needed always additional commands to simplify their work. So I thought if I could mechanize that operation and produce automatically what people were doing manually before. And I call that runcom, meaning running command and so on.
It became instantly popular and was later incorporated into both Multics and Unix. In 1971, Pouzin was asked to develop a national computer network for France. The network was ultimately named Cyclades.
They called me to whether I would be okay for building that system. But of course I said yes, why not? You know.
Pouzin toured the US and Great Britain to study the recently deployed ARPANET, along with Britain's NPL Mark I network.
6 or 7 months, we presented the architecture to the whole set of universities and research centers in France. Each machine was supposed to provide services to the various parts of the administration which were to be using Cyclade. And therefore, they had the freedom to develop their own database or to use database they already have.
The basis of the network's communication was a data transmittal system Pouzin named datagrams, a combination of the words data and telegram. Datagrams are like a postal system for packets of data. The packets can take any route and arrive in any order, unlike in connection-oriented systems, where packets can only go in single file along certain routes. Datagrams could help with the field's next big challenge, connecting networks together into networks of networks, called internets. In 1972, Pouzin co-founded the International Packet Network Working Group.
It was a way to bring together all the teams I had heard of who were involved in designing and building and operating computer networks.
Group members had experimental internets running by the mid-1970s, including the one developed by ARPA that evolved into the global internet we use today. ARPA started on a different path, but eventually incorporated datagrams into its standard.
But finally, they were using datagram. Perhaps, we didn't have the same format exactly because depending on the address size and so on, and bit control bits and so on. But that's details, but the principle was just the same.
Louis Pouzin is now part of a movement in Europe to offer an alternative to the American-dominated domain name service.
Where we started discussing about things which were taboo at the time, discussing the DNS, the name system, which the American didn't want anybody to be part of that. We had a relatively easy way to convince people that domain names should be in native languages, that they should be handled by each country, and so on. If we are very optimistic, we would say the net will be accessible everywhere, no matter where we are, and no matter what the costs are. Computing things will be always difficult. The cost of making it work should be shared by the whole communities of people. Well, that's what I hope.
The 2019 Computer History Museum Fellow Award is presented to Louis Pouzin for the pioneering design and implementation of packet communication networks that led the way to the internet. Please join me in welcoming Louis to the stage.
Good evening, all. Ladies and gentlemen, experts and non-experts. Well, I'm very honored to be part of that meeting, that because of the brilliant number of people who I can met here, including the people I met 10, 20, maybe 30 years ago. And just to tell you a secret, I was born before the internet. And then, of course, when I write a piece of article in the French paper Le Monde, what the new technology was sort of supercomputing, electronic computing, which would do things thousands or 100 million times faster, I was sold on that. So I moved to a company which was dealing with computing. Actually, computing was on punch cards. But it doesn't matter. We had the idea that we would move towards a world in which things would be extremely fast. That's where I moved from company to company so that I could always have the kind of job that I wanted. No, the important thing in your life is to be happy in what you're doing. So if the company makes not you happy, go someplace else. So at the time I was with Machine Bull in France, I was offered, well, I not was offered. I decided that I had to go to the United States because first I didn't speak English. Second thing, I didn't know computing, I didn't know programming, and I had about 40 engineers working in my group, but they did programming, but I didn't know what they were doing. So I was embarrassing, but my boss was sufficiently understanding my problem that he found some place to go to the US to learn what I wanted, programming, English. And he suggested MIT. Okay, why not? I had no idea what MIT was, But then I got not funding, since at that time my company didn't want to pay for anyone go someplace else. So I sort of got a limited arrangement with my company. Let's say if I get sick, when I was in the US, they had a health plan, so they could pay for the Social Security in order for me to return. But except for that, I was free to find money where I could. So I went to MIT I was hired by the computing center, Professor Corbato, even though I didn't speak much English. And he was apparently convinced with my desire to learn something. And I was at MIT 2.5 years, which led me the time to learn how the American work. And that was quite different from the French. So after having understood their technical way of working, managerial way of working, I decided I had enough learned there. I had developed things on CTSS, such as the shell, for example. Everyone knows the shell. So I wanted to save time in running commands on the computing system. But now the shell is well known, that's fine. But when I returned to Bull, they had been hired, the company had been bought by General Electric. And there were a lot of people coming from the US speaking English and so on. Fortunately, I could speak to them. And my boss was actually an Italian, but better thing. So an Italian who understood very well Europe manners. So he was keeping me around to go and trying to sell customers the big machine, General Electric 600. Well, after 2 years, I knew every airport in Europe, and I wanted to have another job. So I asked my boss to get me an idea about that. They say, "Well, you're a special kind of people. You're an engineer, and we have a possible client who wants to do meteorology, the French meteorology. But then, what is meteorology? Well, you compute a lot of parameters to decide what will be the next weather the day after, possibly." At that time, it was already computerized in some labs in the US, but it would take 3 days to get the weather for the next time. So it was a little bit not very practical. But of course, we thought that would get better with the time. Computer would be faster. And second, people would have better algorithms and better observation point, whatever. So my company said, "Well, what if you would take up the contract with the French meteorology? That's something what interested you." Well, I said, okay. And I went to take a seat at the meteorology. Managed to get a little team to work on that. And we developed a system to handle meteorology. But it was not a computer from Bull, because General Electric has apparently given up selling computers in Europe. So the meteorology had other control data systems, which was not Bull. And therefore had to switch company to get with a company representing control data in France. So that's it, no problem. I went there and we built the system in 2 years. Well, it was really some sort of a copy of a Unix system, because control data had no processes. They had just big machines working, a lot of computing at the microsecond, but no real database, no database, and no practical debugging systems. So we had to develop all that on the central computing. It was a different language, and it worked. And after that, we discovered later, 5 years later, that it was Unix. But we had no Unix. Unix was popular at the time. But after that, I went to continue to work on different projects. The major one was Cyclades or Cyclades. That's the French government idea. They wanted, since the United States were developing a lot of computing and for many problems, going from the military to the office systems, to the research systems. So they wanted me, if it were possible, to build a system in France so that they would be able to do the same thing without having to borrow American techniques. Well, remember that at the time, our president in France was de Gaulle, and he was in a very good term with the United States, and specifically because de Gaulle was intending to build an atomic nuclear bomb, and the American had refused to deliver a controlled data machine, which was the fastest computer at the time. So he wanted to be independent. That's why they decided that they had to give me the contract, and I decided it was a good idea. I get again collect a band of people to do that, 5-6 people, just to manage rewriting the whole operating system for controlled data. Well, that was a very interesting project. But once they have finished, after 2 years, they could use it. They used it for 15 years, actually. But they were no longer me, so I had to switch to some other company. Well, I'm finished with this detail. What came out later on, a number of years later, is that things related to computer networks. After Cyclades, which was a network of networks, we were looking at what else we could do around. And you had ARPANET, which had switched from the protocols which was developed in 1973. But we had protocols which were based on datagrams. And this was adopted by the American side in 1983. That means 10 years later. But anyway, that was, I was hoped, because the French people at that time, we had changed government, and the new government was totally uninterested in discussing computer networks. That's what was the opportunity to be in touch with the American colleagues into developing something different. Well, they were developing internet in '93 based on datagrams, as we had done, but with slightly different protocols. But then there was a trend in France to standardize systems. That was the OSI, Open System Interconnection, where I was part, of course, obviously. But then the problem was that systems were still different. There was the IBM dominant system, and there was no real facility to build system independent from what was on the market, mainly IBM systems. So we started to look for a way of being independent. That's where I created OpenRoute, a way of using the internet with different DNS, different domain name system, totally independently from what ICANN was doing. Well, it was not technically difficult. It was just a matter of convincing people that they could work on ARPANET, on internet, without adopting all the constraints that were at the time available with the American software. Anyway, once we had done that, we were expecting, again, some novelties. And fortunately, one of my colleagues, John Day, who had been working on ARPANET when he was young, but he had matured, of course, a lot of the time after that. He had written a book on RINA, Recursive Internetwork Architecture. That means something which could use any existing system but with a different architecture so that all systems would be independent. They could use their particular protocols, their name system, their parameters, and be securely independent, which was not the case in the previous development of the Internet. And at this point, I again put my whole energy into not building because I'm too old, but helping people to promote RINA. That's my job now. We cooperate. We now have a lot of people, 500 researchers in Europe working on that. And recently we have a whole country, which means Armenia. You know where Armenia is? You don't know, of course. It's a little country. A little country. It's not a suburb of New York. It's based middle of Europe, middle of East Europe. So the government decided to use RINA for its development of a new national system. And second, they would create a research center in which they would train people from the whole world to use RINA architecture. And this is going at the moment now. So we are now on a different track. How long it will take to get operational? Well, it's already operational for some companies. For example, AT&T, the telephone company in Germany is now developing on RINA. A hospital I think it's in Oslo, is using also RINA and so on. So it's beginning to catch up. But of course, we need a little bit more of experience to get that more widely accepted. So that's the future. The future is again a new Internet, using, as long as you want, the existing protocols, if you like them, but being able to move gradually to RINA architecture, which is apparently much faster. Thank you.